Hey everybody, this is Tavi from Dashbird, and we have here also Ryan Jones from Serverless Guru. Today will be our first joint webinar, and we will be talking about serverless at scale, migrating legacy systems to serverless, and how to make it work post-transition. So the first speaker would be Ryan. He will be giving a talk about migrating legacy systems over to serverless. And then after that, I will do a piece about when you already are in serverless, when you're building and operating a large-scale serverless application, then how do you make it work day to day? How do you implement monitoring practices, debugging, and overall being well architected? Ryan, over to you. And yeah.
Perfect. Cool. Well, thanks for joining us today, everyone. As Tavi mentioned, we're going to be talking about legacy serverless migrations. That'll be my piece here. So let's go ahead and jump in. So the first thing that we're going to cover here, a little bit of background about Serverless Guru. The Serverless Guru company helps companies innovate faster, reduce operational overhead, and streamline application development by leveraging serverless technologies. We basically help companies skip over the complexity, lay a strong foundation with serverless, and then get to the benefits right away. A little bit about my background. I'm the founder and CEO/CTO of Serverless Guru, co-host of the Talking Serverless podcast and Serverless Economics podcast, and author of the online course Serverless Zero to Paid Professional, and also an AWS community builder as of a few months ago. I started my serverless journey at Nike in the innovation engineering department in late 2018. And from there, it's just been serverless the whole way. So the first thing I want to talk about when we're thinking about legacy systems is just talking about the cloud spectrum. And so the way that I like to think about this is that, you have a whole bunch of different steps to actually get to something like serverless. And so let's just kind of look at what that means at a very high level. So you have on-premises, virtual machines, containers, and cloud functions. And so when we talk about serverless, a lot of times we talk about cloud functions, functions as a service, or now it's actually the umbrella is growing a little bit bigger to backend as a service, things like fully managed databases. So when we think about the cloud spectrum, I definitely want to keep that as like the first focus that I would have thinking about a legacy transition is where are we on that spectrum and where is our legacy app? Because right now with serverless, for instance, and around cloud functions, yes, it may only be 5 years old or 3 years old or 4 years old. However, we are starting to get into a cycle where even serverless apps are becoming legacy systems as well, and migrating those to a better version of writing serverless. Anybody knows that writes Node.js. You take your app, make no updates for 2 years, and you're going to have dependencies breaking all over the place. So that's how I would go about this at first. Look at the cloud spectrum of where you are. And the next question I'd ask is, does your team already have serverless experience? So there's two different routes here. The first route, yes, we already have serverless experience. We already have cloud experience. That's why the cloud spectrum question was relevant. And so now if you do have serverless experience, then I would say identify the key team members who can help drive and evangelize a serverless migration, including training, pattern development, and so on. This is going to be very important later on because legacy systems are not small, right? These applications have been built over many years. They have many different components, and it takes time and resources to go about breaking those apart and moving to something like serverless. And the engineering hours involved in that, the infrastructure as code pieces, they can all be streamlined by having good patterns, good documentation, good training, and starting to build a working group of people that can help evangelize that to the entire organization. If you don't have that internally, the serverless experience or the cloud experience, then what I would recommend is looking for a consulting partner that specializes in serverless migrations or serverless adoption to help train and retool existing employees and help them grow. So one of the key things with serverless migrations or serverless adoption in general is laying a strong foundation. So what I'm going to be calling the serverless acceleration team here, it's also been called the Cloud Center of Excellence or the DevOps team or the Cloud Acceleration team. There's a lot of different terms that kind of mean the same thing, but don't, depending on the organization. DevOps means something different depending on what company you're at. but I'm going to be calling this the serverless acceleration team throughout this presentation. This would be a working group that will help accelerate the rest of your organization, who will focus on building reusable infrastructure as code, practices around building serverless apps, processes around, let's say, development workflow, and so on. Also restructuring existing teams. So as you get into building serverless apps, it starts to become these silos of what is operations, what is development, what is QA, what is writing infrastructure. That boundary starts to get blurred a little bit, and people start mixing together. And what you end up having is people that can help on the backend, the infrastructure as code, the CI/CD pipeline. Because what we're doing is serverless allows us to focus on plugging things together to focus on the product, right? So as we do that more often, the people that are helping make these connections, they're having to do less and less because the abstractions are greater. So I don't have to build a Jenkins pipeline from scratch. I can use Circle CI and things like that. The next thing that we want to do is identify a common service or use case. So the way that I like to phrase this is what service represents 80 to 90% of how other services are built in the legacy system. So when we take a legacy system, let's just say it's a legacy system composed of APIs. The APIs maybe maybe they're constructed in a monolithic structure, and so they're not broken apart into what we call microservices. And so one way that we might start thinking about that is what is the domain boundaries? So for instance, if we have 100 endpoints and 10 of them are related to account, and 10 of them are related to users, and 10 of them are related to feeds, we can draw 3 service boundaries there, and we can say, okay, the APIs that are being done 100 times, one of them looks the same as the rest of the 100, right? So if we can start identifying where the similarities are and where the commonalities are between all these 100 endpoints, then we can draw a service boundary, and then we can start chunking this migration up into pieces, and that makes it more easy to move forward. So what that does is, as I said, draw a boundary by domain, develop reusable infrastructure as code patterns around that use case. So if it is a REST API, if it is GraphQL that you're going to be migrating to with something like AWS AppSync, then what you can do is you can start developing reusable templates, which the rest of your team can use. And taking that example of 100 endpoints and then breaking it up into 10 service boundaries, if we develop a pattern for one service boundary and it's composed of 10 endpoints, and there's 9 more of those services that all have 10 endpoints each, logically we know that if we can develop one, we can reuse it across the rest of them. And so that's where we start to get into the benefit being training and also accelerating service migration. So the common service blueprint here, this is going to be a common theme, is fully migrate the 80 to 90% common service. And so you can do this in different ways. If you do have the internal expertise and you do build that cross-functional team, and you do have a small group of people, 4 or 5 people that are starting to work and actually migrate that 80 to 90%, let's just call it the user service, to serverless. As they're doing that, the process shouldn't just be in isolation. The one thing that we often do as software developers is we don't have documentation in place. We think about testing and think about observability and all those different aspects after the fact. However, this team's goal is not only moving it to like the legacy system, breaking it up and then moving it to serverless, but actually thinking about the entire process, because this team is going to help empower the rest of the development team so they can move things in parallel. So documenting the entire service migration process, documenting the nuances of how your teams build services, using that knowledge to improve training material, and then using the service migration to further leadership buy-in. So once you actually have it migrated, once you have some processes starting to be defined, then you can take that and you can show that to leadership and say, look, we took this, we migrated it, here's the benefits of it, it's real, this is possible. And even if they were already bought in, it's just another mark, another check on the box to making this successful. Now we get to employee training and retooling. So we migrated our first 80 to 90% common service. Now we have to make sure that the other 30 developers on our team, or 50 developers, 100 developers in our organization, all have the type of training that they need to be effective in this new environment. The first thing that we're going to tackle is basic tool training. So infrastructure as code frameworks. You have AWS SAM, serverless framework, you have raw cloud formation, AWS CDK, there's Stackery, there's all sorts of stuff. So making sure that the ISC frameworks and how they operate is understood, as well as other serverless tools, Dashbird being one of them, CI/CD pipelines that you can choose from. All those are going to help make sure that the development workflow is well understood. And the idea here is that if we go back to laying a solid foundation and we think about, yes, we do have serverless experience, so we can build that team internally. If you don't, hiring the consultants. Where that comes into play is now once we get to the training part, having some people that are part of the serverless migration, serverless initiative to help on this training aspect is going to be really valuable because as this first bullet says, it's going to condense years of learning into a happy path. So the more streamlined that we can make this process, the easier it's going to be for everybody to get on board and be able to develop effectively. We're going to familiarize developers with common commands and usage in this period of training. And we're also going to demonstrate service development workflow, testing, and how they can actually see logs, do monitoring, all those type of aspects. Then we actually jump into the pattern training line by line review. So the big reason behind this one is that we did migrate that common service and we can teach from a high level. A lot of stuff focuses on the hello world type of applications. Here's how you build an AppSync API, a GraphQL API. Here's how you build a REST API with AWS, with serverless, but it doesn't go deep enough, right? And so we know that when we're migrating a legacy system to serverless, we have to go as deep as possible to get to actually making that thing work. It's not net new. It's not a completely greenfield application. We actually have to map things over. And so as we take this line by line review, we already successfully migrated one, so now we can actually go deeper into it. So this would be overview of how the pattern is built with the infrastructure as code, plus other components, and explaining why things were built in a specific way. So there's a lot of nuances around building infrastructure as code and things like naming conventions, organization of projects, mono repo versus multiple repos. There's a lot of different aspects of that and different directions you can go. And so being able to start establishing a standard for the team to follow is very important at this stage. Walking developers through how they can replicate the pattern themselves, right? So when we talked about that service boundaries, we've made the users service migrate to serverless. We've already got the infrastructure as code. We're now training on it. Now we can actually show the developers how they can copy that repository, copy that template, modify it slightly, make the tweaks, and then make it work for the other 9, right? And of course, each individual service is going to have their own nuances, their own little intricacies that they're going to have to tweak and modify. But with this, it's going to allow them to at least get a jump start and be able to spin up a lot of the core pieces. And the idea behind this is we've had some templates that we've written at Serverless Guru where it'll be, a VPC creation with a whole bunch of private subnets and all these things. And long story short, it would take, let's say 50 hours or something if you started doing that from scratch, and then you had to create a new environment. And then maybe even the automation takes like 40 to 50 hours the first time you do it. But then if you want to modify and you want to spin up new VPCs, it only takes as long as the CI/CD takes to run, and that could be that could be 5 minutes, that could be 10 minutes, and so you end up saving that entire like 49 hours of time because you have those templates in place. So that's a very important piece of serverless. And so as we're moving through that process, everything should be a template, documentation, training. How do we share that back to the team? Start creating that culture that's giving back to each other. The results of this training is that we're now going to have a baseline established for the team. So developers can replicate the common service for their own services. The wider team has more clarity on why the migration is beneficial. And this is one thing too, is that when you're making a move like this, you have to have buy-in not only from leadership, but also from the team, right? The people that are actually on the ground working. And people have to feel like they're part of it and that they're at the table and that their voice is heard, right? And so by having this one service already migrated, by doing the training, by going through and making sure you're taking questions and answers from the team, they can start to see the benefit themselves. They see how it'll impact their work. And now you have individual people on the team actually helping drive it forward. And that's where you're actually getting a lot more speed than just trying to push from the top. And then further service migrations can now happen in parallel. So this is the goal of all of this. Why did we go slow? Why did we lay a foundation? Why did we focus on documentation, training, all these things? It's now so that we can replicate the developers out across all 10 services and they can start developing in parallel. So now we move quickly. And with that, we invested early to lay a solid foundation, as we talked about. Now we let the development team start picking up services in parallel and moving them. And the development team can multiply their efforts, as we mentioned. And the big one here is that the serverless acceleration team closely monitors and helps out as needed. So the serverless acceleration team, they did the first one, maybe they laid the blueprint, the documentation, the training, they're getting people on board, they're evangelizing, but now they're not just stepping away and just being like, okay, everybody handle it from here. They're actually closely monitoring and making sure they're supporting the team throughout the process. That's where the ongoing support during migration period happens. So everything is still new. We just dropped a huge ball on all the developers' lap, and now they have to figure out how to make it work. And so, although they got the basic training, although we had the pattern training, once you start actually getting to the details yourself, and it's how do I connect this queue to this Lambda to this DynamoDB stream, and make sure that it's efficient and performant, and know all the different layers of that, right? That part is not going to be able to be covered necessarily upfront because we don't know that going in all the different nuances that are going to happen later on. So we do our best to create a general training to map out at 80-90% of the service, but that other 10% can actually be quite a large lift. So during this process, the development team will hit barriers and roadblocks. The serverless acceleration team will provide ongoing support and also identify areas for improvement. So as they're helping support, as they're getting people back on track and helping them fix things they're running into, they're also going to be looking for areas that can be improved overall. So maybe offline testing, right? Maybe testing is like an issue. So we can define patterns for that. Maybe the workflow with the CI/CD to actually deploy serverless apps needs extra tooling or needs further a look into it. Well, we can focus on that too. And so the serverless adoption team, or serverless acceleration team, is closely monitoring, tracking all those improvements, and then constantly rolling things back out to the team. Now we go into edge case pattern development and training. So as the developers are working, migrating things, they go, oh, hey, we use this queue, this SQS FIFO queue. It's not processing fast enough because it only processes it one at a time based on how we set it. Okay, well, let's create a pattern around how to use SQS FIFO properly so that later on, we don't have additional production issues happen that are causing delays. And so with that, we can then create a pattern around it. And so what this looks like is we keep developers focused. So the serverless acceleration team creates new patterns around the edge cases that are hit. They also share these patterns with the entire development team, ensuring that optimal knowledge reuse is happening. And they also support the edge case and develop an internal serverless best practices playbook. So as we're going through that process, we're identifying SQS FIFO, how to do it, DynamoDB, how to do it, how to set up DynamoDB streams properly, how to make sure that we're using Lambdas efficiently. Maybe at first we were streaming something at the end of the Lambda function, but then AWS comes out with this new pattern called Lambda extensions, and we can move that out of the Lambda code. We're freeing up developer time, we're freeing up the amount of stuff that they have to worry about, we're improving the speed of our serverless functions. All those things are benefits, and that's where the serverless acceleration team really plays a key role because now let's say we have 100 functions, we're speeding up every single function. That's real dollars to the organization. And it's also real engineering hour savings because now our engineers are spending less time worrying about this piece. And then we can identify how long did each developer take to worry about streaming something at the end of the Lambda function, like pushing it out to Kinesis stream to then go to like Elk or Kibana. Well, let's say it took 5 hours. Now we can multiply that by the number of services, how often people are rolling out services, number of developers. We have real savings, right? So it's not just the raw compute cost of the Lambda function, but the engineering hours actually matter a lot as well. So with that best practices playbook, we start writing that stuff down, we start documenting it, and now we can actually give that to onboarding for new developers coming in, and we can basically use it as an auditing tool. And this is something that Lego.com actually does as well on their team. Okay, so serverless, successful serverless migration, right? So check mark, we did it. We skipped ahead maybe like 3-4 months here, 6 months, however long it ends up taking based on how big and how many migrations you're actually making to serverless. But after we get through the process, our legacy system has been migrated to serverless. Fantastic. developers are independently building new services. So they have everything they need through this process of migration to build new services. And that's a really key one here. We don't want to get to the migration being done, but then all the developers have no idea what they're doing, right? So even as a consulting company, which would be Serverless Guru, who I'm representing, we're never just filling the role completely, right? It's always about bringing the entire team along because ultimately you want the developers at the company to independently be able to build new services without having to rely on the consulting company for the rest of your existence, right? Um, Knowledge is retained inside the team by retooling existing employees. So we didn't fire all the employees and then hire new people. We helped the existing team who knows the business, who knows how things operate, basically just get another skill set that adds to what they already have. And all the context that they had previously about the legacy system is going to make them move even faster now with serverless. The overhead and maintenance has been dramatically reduced. So now that we're not worrying about potentially the on-premise headaches of actually like racking servers if we're at that point, or setting up virtual machines and having to worry about auto scaling, how fast we're auto scaling, are we scaling back down properly, are we having to SSH into servers and modify stuff, or even containers and other things like having to set up the containers with Docker images, move through container repositories online on AWS ECS or ECR. We're basically just moving straight to the application code itself. And as Werner Vogels from the CTO of Amazon says, we're allowing Amazon to handle the undifferentiated heavy lifting, and then we get to focus on our product. So yeah, that's great. The culture has been influenced to share knowledge and always think about ways to further optimize. So when we talk about this, like your culture change, the big thing here is that as you're moving through this process, it's not just about the serverless migration, it's about changing the entire culture. We want a culture where people that are working at the company are talking to each other. Sounds like a crazy concept, but that's what we're aiming for, right? We want people at the team to feel confident in sharing ideas, talking to leadership, giving feedback, helping improve the process from the internal identifying, like I just said, around the Lambda functions and moving some code out, right? If we're starting to encourage people to think like that, it's going to have a ripple effect out. And something that comes to mind, I believe it was Toyota, is that on their production lines they actually have a ripcord where if they pull it, it stops the entire production line, and anybody on the floor can actually give feedback about how the process could be improved, right? So that approach takes it much further than the serverless migration, and so that's a big part of this, at least from my perspective. So what comes next, right? We did it. We crossed the finish line. Well, we don't stop, right? So I think that's the key thing here. This is always continuous improvement, right? There's no finish line. You may have to tell that there's a finish line to leadership to get them to buy in. There's a start, there's a middle, there's an end. But ultimately, we're trying to create a cyclical system that is going to feed into itself, right? Developers will feed information. The team will consistently keep scaling up as they're going, and we're going to get faster. We're going to build better products for customers, and we're going to just keep iterating on that ad infinitum, right? Like it's never going to stop. So now the serverless acceleration team turns their attention towards internal processes that always get shelved, right? So this may not be serverless. There may be other internal processes that are causing delays. It may be how we handle internal stand-ups. It could be creating like bots for stuff, right? Like this is more just like a general thing. But the big thing is that branching strategy, for instance, on the repositories, how we're doing different branches and deployments. Are we doing preview deployments? Are we creating separate test environments? How easy is it to create different AWS accounts? All those things can end up having real engineering time savings, as well as security impacts and all those things. But typically, those things are going to get pushed to the side because the main meat of it is getting across the finish line, having the legacy system migrated. But in that process, we're going to identify stuff, and that's where we really want to have some attention to that. Next, we're going to work with the architects to design new serverless services and migrate additional legacy systems if there are any left over. So as the serverless acceleration team has been helping the entire organization, they may have more insight into how the architecture side is operating with serverless services, especially depending on if you're using a consulting company and coming in with much more experience from working with different clients. They can help your architects speed up their knowledge as well. So it's not just developers, now it's the architects. And then, of course, additional legacy system transition as well. And then the last bullet point here is building tooling and training further to improve development workflows. So constantly, every day, new companies are popping up. They're working on new tools for CI/CD or for different aspects of the development workflow, like local testing or emulating AWS services. And we're going to be able to find those improvements with the serverless acceleration team, and then be able to create a pattern for it, test it out, isolation, experiment with it. Maybe it's not going to work, but we're going to experiment because the savings of it are going to be massive if it does work out. And then once we do have something, okay, we've got a concrete example of something that works, we're then going to present that back out to the team. We're going to do training on it, record videos about it, and make sure that the team starts moving towards that direction. And I believe that's it. So yeah, that's my that's a lot of information, but hopefully y'all found that useful. Yeah.
Thank you so much. So we do have a question for you as well. So what's a common use case you're both seeing in your projects? And do you have a favorite? I guess that is for serverless projects. Do you have a common use case for serverless that you keep seeing over and over again? Are there like any common things?
So one thing that I think I love about serverless is that because it like there's so many abstractions that you get to see things from a different perspective. And so when it comes to mobile backends, web application backends, desktop app backends, pretty much everything, it runs off of like REST APIs or GraphQL APIs. And so I guess the most common that I see is that people are just building REST APIs or GraphQL APIs. And so we end up having a lot of times where just having those templates for companies is 70% of what they're actually doing. So
yeah, couldn't agree more. I think APIs and kind of that is the most common by far in like also what we are seeing. So I think that no further questions to you at the moment. Thank you so much. I really enjoyed listening. And yeah, stick around. There might be more questions. But I guess now it's my turn. So I do hope that you can see my screen. I'll face you out. So I'm going to be covering building and operating large-scale serverless applications. Quick intro to Dashbird and myself. So my name is Tavi. I'm the CEO and co-founder of Dashbird. I've been a developer for over 14 years. I've been serverless or building different kinds of serverless applications since 2016. I've been an architect in a couple of high-scale serverless projects where we worked with big enterprises and scaled the application to hundreds of millions of invocations over thousands of cloud resources. And from that experience, a couple of years ago, I founded a company called Dashbird. Currently, we're one of the leading serverless monitoring and troubleshooting platforms. And our platform is being used by over 4,000 developers actively, basically every day. And recently, in the last kind of 1 year, we've been focusing a lot on pushing organizations and enabling organizations to be well architected, and kind of that the product strategy and kind of our mission has been more tightly aligned with achieving well architectedness across our customer base and our users. So kind of our mission and what we aim to achieve and aim to bring to the development community is well-architected practices being followed by for serverless applications. And we believe that we can make developers build and iterate faster. We can mitigate risks and help organizations gain confidence in in making fast iterations to their application, building new stuff, releasing new stuff, make informed decisions about their application, and learn AWS best practices and have those practices being enforced across engineering teams, building serverless. And like those are the main reasons why you should look into the well-architected framework as well. Originally, this talk was developed together with AWS, so I'm going to quickly remind everybody what is the well-architected framework and what it consists of. So it's a 5-pillar approach and a framework for basically all of the best ways of building a cloud-native serverless application, what you should be following, and kind of how do you evaluate and audit your infrastructure. There are design principles, and then after each of the pillars, there are questions to test you and kind of encourage you to think like what are the shortcomings and how well architected you are as an organization and as an application. So there are 5 pillars to the well-architected framework. From operational excellence to security, to reliability, performance efficiency, and cost efficiency, and optimization, and like over time optimizing costs. Also, in the well-architected framework, there are lenses, and lenses are basically a way of looking at a specific workload type. So it could be a serverless application, it could be high-performance computing, it could be any other type of workload, and those different types of workloads get looked at through a lens. So for each one of those workloads, there are different things that are important, and you should be aligning yourself with the lens as well. And the documentation for those lenses includes different scenarios for serverless applications, and also enable you to kind of think how to what's the best architecture for your solution, and kind of enable you to play through different scenarios. If we're looking at the serverless lens for well-architected, there's a couple of points that you should be mindful of, and like those are the design principles. Keep everything speedy, simple, and singular. Always think about concurrency rather than total requests, and those come especially important when you have a downstream service in your serverless application that might not work well with high concurrency. Never share anything across the resources. Everything is stateless. Never assume hardware affinity. Orchestrate not in code, but in step functions. Keep everything event-based, and design for failures, duplicates, idempotency from the get-go. So this is what AWS tells you, and like we as a platform try to push you towards achieving those principles and those kinds of ways of thinking about your serverless application. So now coming to actual kind of more real world and what we see within our user base and companies using serverless at scale. The biggest challenges. So the first thing we see when you are at scale is overall visibility into your distributed infrastructure. So what happens is you have maybe migrated from or like built a service that has hundreds of resources or thousands of resources. Those can be functions, but also API gateways, different types of databases, queues, step functions. You have a lot of complexity across a large surface area, and the logic is distributed. There's monitoring data being produced for each one of those resources. And for a team, that becomes quite efficient to work with, and you need the right tools, the right processes, and the right understanding about your system And kind of that's the biggest problem we see, or like the biggest challenge. And that translates to spending a significant amount of time debugging, troubleshooting, trying to understand the state of your application, and like having a confidence about if your system is working well or not. The third thing that we see a lot of challenge and kind of a lot of like undifferentiated work being done by engineering organizations is failure alerting and catching incidents, being aware of problems in your service, and maintaining alarm coverage for those scenarios. And the last thing is maintaining posture and best practices and configurations and all of those to follow the best practices of AWS. And this becomes difficult when you have a lot of microservices, a lot of team members. You're changing a lot of stuff, but doing deployments and maintaining the same amount of like best practices, following all of the things you should be following, becomes difficult over time. So a couple of things that we think how tooling can help in those cases. And kind of this is also how we're thinking about our product strategy, is centralizing and making the monitoring data available. So this means giving engineers the ability to interrogate monitoring data at scale really easily and reducing the time it takes to understand different aspects of the system, understanding the health of your system, and overall just getting a feel of what's actually going on. The other thing that you should rely on tooling is reducing the time to discovery. So you shouldn't be like investing too much time and building your own alerting systems or managing alarms manually. This is also what can be abstracted and automated away. Maintaining posture and enforcing best practices is also should be an automatic and abstracted process rather than a manual one. Abstracting threat detection and having coverage for unknowns is also something you should be relying on tooling. And overall, managing all of the monitoring data, managing the infrastructure that holds that monitoring data is also something that's undifferentiated. Also, we believe that tooling can help you enable learning and understanding your system and the way it changes over time, and help you make informed decisions. So considering all of this and working with different companies using serverless, we've put together an approach that we follow in Dashbird and kind of a product strategy that is based on the previous points. So, for example, the Dashbird platform is based on 3 core pillars that make up our platform and enable our customers to be successful. So the first thing we do is we provide a single pane of glass and a central store for all of your monitoring data. So there's always one place you can go and look at anything about your system. It's you can build complex queries. You can look at dashboards of microservices. You can look at cold starts and like all the way from an account level and microservice level into a single transaction level. So that's the first thing. The second pillar is we automate and abstract all of the failure and threat and risk detection across the stack. So that means analyzing logs, metrics, and then figuring out what you should be paying attention to. The third part is the well-architected lens. So we have an overview and all of the things we continuously check, and then make a report of what is the current state of your application and infrastructure. So let's dive deeper into each one of those pillars and kind of make them like paint the picture. So when we're centralizing and democratizing monitoring data, we aim to give back a lot of development time to focus on the actual product and the customers rather than debugging, troubleshooting, and understanding the system, and like also not building the monitoring solution yourself, not having to develop the domain knowledge about like details of monitoring and details of what to bear in mind for all the services. So we help organizations code through logs, bubble up meaningful information, and structure all of the activity data for applications. The second thing is the failure detection. So Dashbird features over 80 checks now that continuously check for conditions that should not be there. Those include exceptions in your logs, timeouts, configuration issues, but also metric conditions for APIs, databases, queues, to detect things like a high delay or a memory overage, anything critical that requires immediate attention is covered for. And we believe that with managed services, with serverless, the same conditions and the same alerts should always be present, regardless of like what the underlying business logic is. You should be able to do the monitoring pretty much the same way in most cases. And the third part is the well-architected checks. So we continuously check things that AWS recommend you to, and also what we've seen from the community and our users doing and building over time. So those include things like, is your runtime upgradable? Are you tagging your resources correctly? Is something abandoned? Are you, do you have API gateway logging enabled? Things like that across all of your managed resources, and give you a report of what the state is. How are you doing with security, with reliability, with performance efficiency, and the other pillars. So with this approach, for serverless organizations, we're able to help them succeed, and that is specifically in 3 factors. So we increase the reliability and mitigate the risks of incidents, and that's the biggest thing we do. That's the biggest value we have found that is a challenge for serverless users. The second part is we enable engineering teams to be a lot more efficient over time and focus more on the customer rather than doing and like solving challenges and creating undifferentiated value. And we help our organizations to be aligned with the best practices of the industry. So I can show you a couple of things about the product as well. I hope you can still see my screen. So our product works without any instrumentation. This is 2 minutes away from deploying a CloudFormation template. And after that, we surface all of the inefficiencies, all of the code exceptions, and all of the posture problems that you have with your application, and give it to you in a single pane of glass where you can easily look at different types of events with different severity and order them to be reported to your Slack or email. We also enable you to go deep into invocation level, look at different logs, metrics, tracing data, and efficiently move around in different parts of your cloud stack in your monitoring data and understand the state of the system. And we give you an aggregated report of the well-architectedness of your infrastructure. So that's it for me. I'm happy to take questions as well. Let's get Ryan back here. So we have a question. At what stage of the migration should a company be thinking of operational excellence? In our experience, it's the sooner the better. So the kind of the challenge is that if you've built everything already, it takes a lot more to right the ship, and the quicker you get feedback to your problems, and the quicker you are able to kind of learn what the best practices are and how you should be building and where are inefficiencies, the sooner you can actually start implementing those changes. So I think right away. So I think that was the only question. Ryan, do you have anything to add?
No, I mean, I agree fully with what you said. We often get hired to come in and help clean up messes that end up happening from just trying to go too fast, too quickly, and then there's a whole bunch of infrastructure all over the place, a whole bunch of things that were connected haphazardly, and then now it's like, how do we actually make our serverless app production ready, and how do we make sure that the infrastructure as code and all the components are following some sort of standard and best practices. And so, yeah, I would definitely just reiterate, definitely think about that stuff early on, because it may take longer upstream, but the downstream costs of having all your engineers just not really having the structure in place can cost a lot more.
Absolutely agree. So I think that's it. Thank you so much for listening. It was a pleasure to talk to you. I think this podcast or this webinar will also be available after the fact. So this will go on YouTube, and there will also be a link shared to all of the people who signed up. So feel free to check it out. And yeah, thank you.
Awesome. Thanks so much.
Okay.